Hello, my name is Hasan Zerze. I would like to talk about limit, its definitions, namely the informal and formal definition of limit, and I'm going to give a couple of examples to illustrate. Let me start with the informal definition of limit. So if you write lim x goes to a, fx is equal to L, this means as x approaches a, the value of fx approaches L. And if we show this in a graph, it's going to be something like this. xy, if we have a function of x like this, and if you have the point x is equal to a here, when we approach x is equal to a on the x-axis, we are gonna move on this curve fx, and the value of fx is gonna get close and close to some value which is gonna be L. So as I say, this means that as we get close to a, the value of fx gets close to L. So this is what limit is. Let me go over a couple of examples. So the first example I have is limit x goes to 2, x minus 3. So when we start with some value and get close to 2, what value we get for this one? So to understand this, we can prepare a table x versus fx, and we are gonna get close to 2. For example, if we start with 1, 1.5, and then 1.8, then 1.99, and even much closer to 2, 1.99999, and then we can do a similar job and use much closer values to 2, and then ask the question what the value of fx is for when we get close to 2. Let's estimate the value of fx here. It's going to be 1 minus 3 minus 2 minus 1.5 for this. For 1.8 it's minus 1.2. For this 1.002. For this minus 1.00001. So it looks like as we get close to 2, the fx gets close to minus 1. So this should be minus 1, but there should be a question mark here, because although we are getting close to minus 1, we need to make sure that if I do this job further and further, I'm always get close and close to minus 1. So we can only understand this when we have the formal definition of limit, but for the time being I'm giving an intuitive picture of what is going on. So another example is, so before I go to the other example, let me there's something I need to tell you. Instead of preparing this table, you can say, oh, I can just put this value x is equal to 2 instead of insert this as x, and then find minus 1 already, so we don't need to do all these tables and so on. But I'm gonna give a counter example for this one. So for example, if we have limit x goes to 1, what is the value of x squared minus 1 divided by x minus 1? So if we just insert the value, it's going to be 1 minus 1 divided by 1 minus 1, which is going to be 0 divided by 0. This is indefinite. So there is a problem in here. But if we prepare a table as we did here, if we prepare a table instead of inserting the value of 1, so what we are going to do as we did here, we are going to get close and close to 1. Let's start from 2. This time let's reduce the value and approach 1. For 2 it's going to be 3. The value of this is going to be 3. For 1.2 it's going to be 2.2. If you insert 1.1, 1.01, blah blah, you're going to get 2.1, 2.01, and so on. So it looks like as you approach 1, this value approaches 2, but you need to do this all the way through and use much closer values to 1. So the answer is 2, but we cannot, as I said, we cannot be sure definitely before we give the formal definition of limit. So this is what we have. So, but to clarify things, I need to define the limit now formally. So the formal definition of limit comes. For a function f(x), limit x goes to a f(x) is equal to L if the followings are satisfied. One, f(x) is not necessarily defined at x is equal to a. But must be defined in an interval that contains a. 2, for an arbitrarily given epsilon greater than 0. There is some delta greater than 0 such that x minus a less than delta implies f(x) minus L is less than epsilon. So let me show you what this means. So if we plot a function f(x), so as we said, f(x) is not necessarily defined at x is equal to a. So maybe it's not defined at x is equal to a, like in this example it was not defined at x is equal to 1, but for arbitrarily given epsilon greater than 0, which defines a closeness or proximity in y-axis. So if we have epsilon here, for a given epsilon, there is a value delta such that if we are close enough to a, now we define what close means. So if the chosen value of x is closer to a, than the value of delta, the value of fx is going to be within this interval. So if somebody gives you a value of epsilon which is greater than 0, then we can always find a value of delta such that in this interval the value of the function is going to be within this plus minus epsilon value. So this is what the formal definition of limit is. So let me give an example to clarify. Example, show that limit x goes to 3, 2x minus 8 is equal to minus 2. So yeah, for this one we need to assume that epsilon is given. Assume epsilon greater than 0 is given. And we are going to find some delta, maybe a function of epsilon, maybe something dependent to epsilon, such that this one implies this. So for 2x minus 8 is less than epsilon given, then the value of fx, 2x minus 8 minus the value of the limit, minus 2, is less than epsilon. For this to happen, we need to have 2x minus 6 less than epsilon, and from this x minus 3 is less than epsilon divided by 2. So which means that if we choose delta is equal to epsilon over 2. So if epsilon over 2 is given, then just choosing delta is equal to epsilon divided by 2 will work to satisfy this, because x minus a is going to be less than delta, because delta is epsilon divided by 2. And if this is true, then we know that fx minus L is going to be less than epsilon, which proves that the limit of x goes to 3 of this function is minus 2. So in the next videos I'm going to give I'm going to talk about the properties of limit, and I'd like to thank you to listen to me, and see you in next videos.